This video is on qualitative graphs. We are comparing a speed versus time graph to a distance versus time graph. Let's look at the speed graph first. What is happening between, let's say, A and B with the speed? Okay. You should notice that the speed from A to B is remaining the same, but the car is moving. Okay, so or the person is moving. So we'll say, he's increasing his distance over time. So we'll say he's moving like that. Constant speed. What happens from B to C with the speed? Okay, so you're going to notice the speed slows down. So you're now more gradual, and then you eventually stop. Okay, at C you stop. So I'll put A, and then from B to C, and at C you stop. And then you are increasing your speed at D. And so that's what the graph looks like if you're talking about distance. Constant speed, so you're moving, slows down, then stops, and then increases the speed. Let's look at a graph of Peter's father driving from 0 miles per hour in his driveway, gets up to 30 by the time they are 1 mile away from home. He then maintains that speed. At 3 miles away from home, Peter's father has to slow down to 20 in order to turn a corner, and then speeds back up to 30 miles per hour. When Peter's father is 6 miles away from home, he slams on the brakes. I would like you to pause the video and sketch this graph. Go ahead. Alright, so you should have a sketch on your paper that looks like this. From 0 to 1, he increases up to 30. He maintains that speed. You have a constant speed until 30, and then you dip down to 20. You go right back up to 30, and you stay there until 6 miles, and he slams on his brakes, so he goes down to 0. Okay, and then I'm going to do one more, and I'm going to make it a full screen so you can see it. Maybe like 75 is fine. All right. Jake is very sleepy when he starts out on his 5-block walk to school. About a block from Jake's house, he decides to stop at the convenience store for an energy bar. He walks another block when he hears Joey, his friend, calling his name. Jake stops to wait for Joey to catch up. A block from school, there is a busy intersection that Jake and Joey need to wait for traffic before they can cross the street. Jake notices that if they don't hurry, they will be late for school. Jake's mom will ground him for going over to Joey's house after school, and there is no way that Jake wants to be grounded. Alright, so first you need to decide what your variables are and where they go. Okay, you usually, like this is happening over time, so you usually have time as your x-axis variable or your independent variable. And over here you have blocks. And you have 0, 1, 2, 3, 4, and 5 blocks. Okay, go ahead and do your graph. Okay. At this point, you should have already done your graph. You should not just be watching the video to get the answers. You should be actively trying and correcting as you go. You are going to start at 0 blocks, and you are going to stop at 1 block for the convenience store. You're going to walk another block. So I'm at 2. You're going to stop again to wait for Joey. You go until you are at a block from school. So I'm going to go up until 4. And I have to wait for an intersection, and then I finish my route. So you actually stop 3 times, and I'm going to highlight those. You stop for the convenience store, you stop to wait for Joey, and you stop for the busy intersection. And so you stay at that block for a little bit of time. So that's why the distance hasn't changed for blocks 1, 2, and 4. That's all we have.